Good morning to everyone. I'm Dr. Sumi MS. The name of the course is Object Oriented Programming, and today's lecture topic is Multi-threaded Programming from Unit 3 Exception Handling and Multi-threading. On completion, the students will be able to define what a thread is and also differentiate between process and thread, understand the advantages of multi-threading in Java, and differentiate between multi-threading and multitasking, and explain the different states of the thread cycle. Thread. A thread is a lightweight subprocess that defines a separate path of execution. It is the smallest unit of processing that can run concurrently with the other parts or other threads of the same process. Threads are independent. If there occurs exception in one thread, it doesn't affect the other thread's operation. A thread mostly shares a memory area. A thread is executed inside the process, and there is context switching between the threads. That means the processor can change from one task to another without affecting the task or without creating any conflicts among the tasks. There can be multiple processes inside the operating system, and one process can have multiple threads. So here an operating system can have multiple processes, and within a process there can be multiple threads being present, and each of the threads share a common memory, but at the same time a separate path is being used for their execution. The difference between thread and process. Process is a heavyweight program, whereas thread is a lightweight process. Each process has a complete set of its own variables, and threads share the same data. Process must use inter-process communication to communicate with their sibling processes, but at the same time threads can directly communicate with each other with the help of their shared variables. Cost of communication between processes is high, whereas cost of communication between threads is low. Process switching uses interface in operating system. Thread switching doesn't require calling the operating system. Processes are independent of one another, whereas threads are dependent on one another. Each process has its own memory and resources, whereas all threads belonging to a particular process share a common memory and resources. Creating and destroying processes takes more overhead, whereas it takes less overhead to create and destroy individual threads. Multi-threading. A program can be generally divided into a number of processes, and these processes each can have multiple threads. Multi-threading is a technique of executing more than one thread that is performing different tasks simultaneously. Multithreading enables programs to have more than one execution paths, but these paths are executed concurrently. Each such execution path represents a thread. For example, one thread is writing content on a file, and at the same time another thread is performing spelling check. Advantages of this multithreading is that the threads are lightweight when compared to processes. They share the same address space, and therefore they can share both data and code. And context switching between threads is usually less expensive than between processes, and the cost of thread communication is lower than inter-process communication. Threads allow different tasks to be performed concurrently, and also the computational time of a thread is lesser than that of a process. Through multithreading, efficient utilization of system resources can be achieved. Multitasking. Multitasking is a process of executing multiple tasks simultaneously. It is mainly used to maximize the utilization of CPU. Multitasking can be achieved in two ways. One method is multiprocessing, that is process-based multitasking. It is a feature of executing two or more programs concurrently. For example, process-based multitasking enables us to run the Java compiler at the same time while you are using a text editor or visiting a website. The other multitasking is thread-based multitasking, which is nothing but multi-threading. It is a feature that a single program can perform two or more tasks simultaneously. For example, a text editor can format text at the same time while it is printing, as long as these two actions are performed by two separate threads with separate path. The difference between multi-threading and multitasking. So multi-threading, it is a process is being divided into several sub-processes called threads, which have their own separate path of execution. Whereas in multitasking, it is the execution of more than one task simultaneously. And in the case of multi-threading, one or more number of processors can be employed, whereas in multitasking, a single processor is carrying out all the tasks. And the number of process that is being executed, various components of same processes are being executed as threads at the same time. And in multitasking, one by one the processes are being executed at a time. And number of users, usually there will be one user handling multi-threading, whereas in the case of multitasking, more than one user is there. And memory space, threads are lighter weight and they share the same address space, whereas processors are heavyweight tasks and they require their own separate address spaces. Communication between units, inter-thread communication is less expensive, whereas in the process the communication, inter-process communication is expensive and it is limited. Context switching from one thread to the next is lower in cost, whereas context switching from one process to another is costlier. Thread model or thread life cycle. A thread can travel from its stage of object creation to object removal. This is known as the life cycle of thread or thread cycle. A thread goes through various stages in its life cycle. At any time, a thread always exists in any one of the following states. So first we have new state, following that runnable state, running state, waiting or timed waiting or blocked state, and finally terminated state or dead state. New state. A thread begins its life cycle in the new state. It remains in the state until the start method is being called on. Once the start method is invoked, then the thread moves to the runnable state. That is, the thread is now becoming runnable. Following that, a thread enters into running state if the thread scheduler has selected it. And during the running process, the thread can also remain in the waiting state if it waits for another thread to perform a task. In this stage, the thread is still in an alive condition. Terminated state. A thread enters the terminated state once its task is being completed. Quiz questions on multi-threaded programming. Differentiate between process and thread. Write down the advantages of multi-threading in Java. Differentiate between multi-threading and multitasking. Explain the different states of thread cycle. Thank you.